So far we have made 2 ATP and 4 NADH in glycolysis and a link reaction together. And we've so far lost 2 carbons as CO2, leaving us with 4 total carbons from that original glucose molecule in 2 different acetyl coenzyme A's entering the mitochondria. The next step we have is called the Krebs cycle, also known as the citric acid or tricarboxylic acid cycle. It's labeled up here as TCA cycle, which is the tricarboxylic acid cycle. Carboxylic acid cycle, or Krebs, or citric acid. Either of those are proper names for the cycle. It occurs in the matrix of the mitochondria. And the general process works like this. You remember this guy, pyruvate, right? Well, if we do have oxygen, this pyruvate is going to enter attached to an acetyl coenzyme A. Again, don't forget we lose some CO2 right here. We'll deal with this pyruvate molecule individually, but keep in mind that this process happens twice per glucose molecule. But we'll deal with just one turning in the cycle here. Loses one CO2. You have 2 carbons attached to the acetyl-CoA. They are going to bind with a 4-carbon molecule and form a 6-carbon molecule. This one is known as citrate. There are names for all of these intermediates, and there's many intermediates in here, but we're not going to go through the naming them. Citrate's just interesting because it's part of why this is called a citric acid cycle. But yes, 6-carbon molecule. You have some intermediate changes, some oxidations, and things like that. You end up losing a carbon right here as CO2, right? Here's the carbon. You're going from 6 to 5. One of them is being lost to CO2. And you're generating an NADH molecule. You're storing electrons. So this next step, you go from 5 carbons to 4 carbons, meaning you've lost a carbon. It's being lost to CO2 right here. And you're storing that energy released in that carbon-to-carbon bond in the form of an NADH molecule, our electron carrier. Stocking them up again. During this step down here, you do generate 1 ATP molecule. Over here, you're going to generate 1 FADH2 molecule. And you're also going to generate 1 more NADH molecule in this cycle. So, let's go through our total accounting. Now, you don't need to remember everything about the citric acid cycle. It is nice to be able to follow the carbons and see how this works and see why it's called a cycle. And it's because this final 4-carbon molecule you are left with gets recycled. And another 2-carbon acetyl-CoA molecule comes up, merges with it, and you end up with more citrate. Of course, this coenzyme A will also go back out here and pick up another 2 carbons from one of those pyruvate molecules that we see out here. Just keep that in mind as well. So let's go ahead and go over what we have so far. I'll review this again every slide. We started with 1 6-carbon glucose molecule. We got 2 3-carbon pyruvates from glycolysis, and the important result of that was 2 net ATP and 2 NADH molecules, electron carriers. Electron carriers. These are going to be really important. Link reaction. 2 pyruvate molecules are oxidized and added to coenzyme A to form acetyl coenzyme A. 2 carbons are lost to CO2 in this step, and 2 NADH are formed. Okay. The Krebs cycle. So far, what we have formed here, again, those NADH, I'm going to say this every time, the electron carriers. Electron carriers. We're storing up electrons in these little piggy banks that we're fixing to break open here in the next cycle. Krebs cycle, 6 NADH and 2 FADH2. Both of these, again, and I know this is getting redundant, but I just want you to know, these are electron carriers. Electron carriers. And we've also generated from the Krebs cycle around 2 ATP and 4 carbon is lost as CO2. So far, we've lost all the carbon that our original glucose molecule had. We've stripped all of that carbon of its energy. We've exhaled the CO2. All the CO2 made from this process gets exhaled. And we're ready for the next step. This next step is the most important thing we're going to have generated from these steps is NADH and FADH2. These are the most important molecules to form during these first 2 steps. The reason for that is because they're going to help us generate a lot more energy. And I would like you to take note of the amount of ATP produced so far. So far we have, let's see if I have okay, I do have a grand total here. 4 ATP total so far. Not that much in the grand scheme of things. That's not a lot of ATP for these processes to have produced. So we're going to need a lot more than that if we're going to generate things like muscles in our body. So we'll talk about that a little bit in the next video.